Hello guys, in this video we are going to discuss about the FET parameters. The performance of the JFET is determined based on the following parameters. First one is the dynamic drain resistance RD. Just a minute. The dynamic resistance of JFET, also known as its AC resistance, is measured around the operating point. It is defined as the ratio of small change in drain to source voltage to the small change in drain current at constant gate to source voltage VGS. Practically, it is obtained from the slope of the drain characteristics curve. Mathematically, it can be written as RD is equal to delta VDS by delta ID at VGS constant. Like we have defined earlier, it's the ratio of small change delta in drain to source voltage VDS to a small change in drain current ID at constant gate to source voltage VGS. So next one is the transconductance. Transconductance is denoted by GM. The transconductance is also known as mutual conductance. It is defined as the ratio of small change in drain current to the small change in gate to source voltage at a constant drain source voltage VDS. That is mathematically given as GM is equal to delta ID by delta VGS at VGS is equal to constant VDS, drain to source voltage constant. So as we have defined, GM is the ratio of small change in drain current ID to the change in gate to source voltage VGS at VDS, drain to source voltage constant. Now the amplification factor. It's denoted by mu. The amplification factor mu is defined as the ratio of small change in drain to source voltage to the small change in gate to source voltage at a constant drain current ID. That is represented as mu is equal to delta VDS, change in drain to source voltage, to the change in gate to source voltage at ID constant. So the next step will be first let them be equations number 1, 2 and 3. So the relation between mu, GM and RB can be given by firstly considering mu. We know that mu is equal to delta VDS by delta VGS, the ratio of change in drain source voltage to the gate to source voltage, right? So multiplying and dividing this with delta ID, the above equation can be written as mu is equal to delta VDS by delta ID into delta ID by delta VGS. We have delta ID and delta VGS in the denominator same, delta VDS and delta ID at the numerator same. So since RD is equal to delta VDS by delta ID and GM is equal to delta ID by delta VGS, this equation 4 can be written as, these are from equations 1 and 2. Equation 4 can be written as mu is equal to the same, so RD into GM. This is the relation between the transistor parameters, FET parameters. Mu is equal to RD into GM. Amplification factor is equal to dynamic drain resistance into transconductance. Thanks for watching.